everyone, my name is Aaron Bradley. This is my teaching video for Physics 106 at BYU. My topic is constructive and destructive interference. I've made a couple edits within this video, so don't mind me wearing a different shirt or looking a little different. All right, let's get started. So constructive interference is basically when two waves come close to one another. Their effects add together. So when two waves of the same wavelength interact and they're aligned, they lead to a new curve that is bigger than the original wave. So let's look at some examples. So take these waves, wave 1 and 2. You can see that their crests right here of wave 1 and the crest of wave 2, they're exactly aligned as well with the troughs. Wave 1 and wave 2, their troughs are in the same position, same wavelength, so then it would result to add together and they have a larger crest and a larger trough. So wave 1 you have X, wave 2 you have X, that would add together to be 2X. When this happens, it's called superposition, which basically produces pure constructive interference. Because the disturbances add, pure constructive interference produces a wave that has twice the amplitude of the individual waves, but the same wavelength. So I have a video that I wanted to show you. It's a quick example. So as we watch this video, watch how when both of the people on the left and right, as they raise their hands, the wave is going to meet in the middle and it's going to become twice as large. So let's watch this. So that wave in the middle is twice the amplitude. Pretty cool. So we just talked about constructive interference. Now we'll talk about destructive interference. Basically, this is just when the two waves that come together, wave 1 and 2, they're on opposite sides of the x-axis. And so when they come together, they'll actually cancel each other out. So let's see an example of that. So here we can see that wave 1, it is, let me get my pen out. While this is going up and then down, we can see that wave 2 is just the opposite. It's down, then up. So when these two waves come together, the resultant wave is canceled out. It's just a straight line. Let's see a video on this one. Like, can explain it pretty well. So let's watch this video and see what happens. So this would be a good example of destructive interference. They're going to swing the rope in opposite directions, and when they meet in the middle, they kind of cancel out. And it's canceled out. It's a pretty cool example. So why exactly do we care about this? Why is it cool? If you look at this illustration, you can see how this works. Notice that the two waves, the one coming from the noise canceling headphone and the one associated with the ambient noise, they have the same amplitude and frequency, but the crests and troughs are arranged so that the crests of one wave line up with the troughs of the other wave and vice versa. So in essence, the two waves cancel each other out, and this is called destructive interference. This happens so that the listener can focus on the sound that he wants, which is pretty cool. Another really cool application of the noise canceling is actually in our cars. So a lot of people who have the pockets and the money to buy a an expensive car, Bose actually puts in noise canceling technology so that when you're driving, noise from outside or from your tires, sensors inside by each seat will pick up that noise and basically just create a wavelength of on the opposite side. So to just create destructive interference. So it's pretty cool. There's a link here that will take you to the page that has a really cool video explaining that, but we won't get into that here. So I have a couple of quiz questions for you guys just to make sure we're understanding this. The first one is, destructive interference occurs when the crest of one wave lines up with blank of another wave. So in destructive interference, it's the crest is lining up with the trough of another wave, so A. Another quiz, in constructive interference, the two waves' amplitudes are blank. Take a couple seconds. So in constructive interference, the two waves' amplitudes are C, added to produce a larger amplitude. And then the last quiz question, in observing two interfering waves, the amplitude of the resulting wave can be found at every point using the principle of blank. So the answer to this one is E, superposition. So another reason this constructive and destructive interference is important is because in physics we talk a lot about wave optics. Wave optics is simply just the study of interference, diffraction, polarization. It's just how they behave. Thomas Young, an awesome scientist, he talked a lot about this, and he had a couple experiments. The famous one is the double slit experiment. You can see there on the left in figure 27.10. When he shined a beam of light through slits, he noticed that because of how the behavior of light works, on the screen further back you see different patterns. And we're not going to get into that, but for the purpose of this video, it's important to understand constructive and destructive interference so that you can understand different experiments later on in physics. These are all my references that I used, and thank you so much. I hope you enjoyed that.